As the first whispers of winter brush against your window pane, imagine yourself wrapped in a blanket of soft, endless snow, your breath slowing to match the gentle rhythm of falling flakes. Close your eyes, let the world fade, and step into a dreamy realm where science unfolds like a lullaby, revealing the serene secrets of the season. This is your invitation to a tranquil journey through winter's wonders, a tapestry of calming facts woven into a narrative that invites slumber. We'll begin deeply, sinking into the quiet origins of winter itself, then explore its phenomena with hooks that draw you further into peaceful contemplation. Let each word carry you like a snowdrift, soft and unhurried, toward restful dreams. You're floating above the earth, a silent observer in the vast cosmos, as our planet tilts ever so gently on its axis, leaning away from the sun's warm embrace. This is the hook that pulls us into winter's story, the subtle dance of orbital mechanics that transforms the world into a hushed sanctuary. The science of winter starts here, with the Earth's 23.5-degree axial tilt, which causes the northern hemisphere to face away from the sun during these months, leading to shorter days and longer nights. As sunlight strikes the southern hemisphere more directly, our side of the globe cools, inviting a season of introspection and renewal. Delve deeper. This tilt isn't a flaw, but a cosmic gift, creating the rhythm of seasons that allows life to rest and regenerate. Without it, the world would be a monotonous equator, devoid of winter's calming pause. In fact, winter solstice marks the shortest day, when the sun hangs low, casting long shadows that stretch like sleepy fingers across the land. It's a time when the soil rests, replenishing nutrients for spring's rebirth, shedding old growth in a quiet cycle of renewal. During this period, the Earth actually orbits closest to the sun, a perihelion paradox where proximity brings cold, not heat, because of that elegant tilt. Feel the serenity in knowing that winter isn't chaos, but a precisely choreographed ballet of astronomy, designed over billions of years to balance our world. As you drift further, envision the winter sky clearing, stars twinkling sharper in the crisp air. The cold dries the atmosphere, reducing humidity that blurs summer views, making constellations like Orion the Hunter stand out in vivid relief. This is winter's astronomical embrace, a canvas for stargazers to lose themselves in eternity's glow.
What if every snowflake was a unique whisper from the sky, a frozen poem crafted in the heavens just for you? As you lie there, eyes heavy, imagine catching one on your tongue, its intricate design melting into memory. Snow isn't mere weather, it's a masterpiece of physics and chemistry, forming high in the atmosphere where water vapor clings to tiny dust particles, freezing into hexagonal prisms that branch out in endless variety. Each snowflake begins as a microscopic ice crystal, growing as it falls through varying temperatures and humidities, no two paths identical, ensuring no two flakes are alike. This diversity arises from the molecular structure of water, hydrogen bonds forming symmetrical lattices that evolve uniquely based on environmental conditions. Snow is 90 to 95% air, trapped in its fluffy structure, which is why it insulates so well, muffling sounds and creating that profound silence after a storm. When fresh snow blankets the ground, it absorbs sound waves, reducing ambient noise by up to 60%, turning the world into a natural, soundproof chamber for peaceful slumber. But snow's relaxation goes beyond quiet. It's a thermal guardian. Animals burrow into it for warmth, as the air pockets trap body heat, maintaining a cozy igloo-like environment even in sub-zero temperatures. Scientifically, snow's color, pure white, reflects all light, but deep layers can appear blue due to light scattering, much like the ocean's depths. And in rare Arctic conditions, algae tinted pink, a soft watercolor stroke on nature's canvas. Snow can even fall at temperatures above freezing if it starts high enough, defying expectations in a dreamy twist of meteorology. Or consider snow squalls, brief, intense bursts dropping inches in minutes, yet leaving a calm aftermath. These phenomena remind us of winter's gentle unpredictability, a lullaby with occasional soft crescendos. Let this imagery soothe you as we transition to the creatures that embrace winter's rest. In the hidden burrows and dens of the forest, animals curl up like living secrets, their hearts beating a slow rhythmic drum to winter's tune. What mysteries lie in their hibernation, a state of profound peace where survival meets serenity. As you relax, picture a bear nestled in its cave, body temperature dropping, breaths shallow, conserving energy in nature's perfect pause. Deep exploration. Hibernation isn't sleep, but a profound metabolic slowdown. Animals like bears, hedgehogs, and bats lower their body temperature by up to 20 degrees Celsius, heart rates plummeting from hundreds to mere beats per minute, using stored fat to sustain them through scarce months. This torpor saves energy when food is rare, allowing smaller creatures especially to endure. Migration would drain them, but hibernation recharges them. Bears enter in lighter form, rousing occasionally, their bodies recycling waste without eating or drinking for months.
Not all flee or sleep. Some adapt actively. Gray wolves become more playful in snow. River otters slide on icy banks, embracing winter's joy. Migrators like birds and monarch butterflies journey south, guided by magnetic fields and stars, a calming testament to instinct's wisdom. Animals in polar regions aestivate in summer heat, but hibernate in cold, flipping the script in dreamy symmetry. These adaptations foster a sense of harmony, reminding us that rest is essential, just as winter invites us to slow down. Now lift your gaze to the heavens for winter's most ethereal display. High above, the sky comes alive with ribbons of green and purple, swirling like silk in a cosmic breeze. What if these northern lights were nature's lullaby, painted by the sun itself? Surrender to their glow, a phenomenon that turns night into a dreamscape. Deep dive. The aurora borealis arises when solar wind, charged particles from the sun, collides with Earth's atmosphere, exciting oxygen and nitrogen atoms that release light in vibrant hues. Greens from oxygen at higher altitudes, pinks and purples from nitrogen lower down. These displays peak in winter's clear, dark skies, often under the auroral oval near poles like Norway or Alaska. Solar storms amplify them, but even quiet nights can sparkle if you're in the right spot. Ancient myths saw them as spirits or winds, but science reveals a protective magnetosphere shielding us while creating beauty. Winter's low humidity clears views, making auroras more visible, a relaxing reward for cold nights. As the winter winds hush the world into stillness, let's sink even further into the enchanting science of hibernation, a profound state where animals surrender to a restorative pause, their bodies becoming vessels of quiet efficiency. Imagine curling up in your own cozy nook, heartbeats slowing like a distant lullaby as we expand on these serene facts. We'll hook you with wondrous revelations and explore deeply, drawing from the intricate biology that allows creatures to thrive in winter's embrace, all while inviting you to drift toward peaceful dreams. The breathless miracle, surviving without air or food. What if, in the depths of winter, animals could defy the very essence of life, halting their breath for hours or recycling their own bodies to endure? This is the mesmerizing hook of true hibernation, a metabolic marvel where some species, like the Arctic ground squirrel, drop their body temperature to below freezing, down to -3 degrees Celsius or 27 degrees Fahrenheit, and survive without oxygen for extended periods, their cells adapting in ways that seem almost otherworldly. As you relax, picture this squirrel nestled underground, its heart beating just once every few minutes, conserving energy in a state so deep it borders on suspended animation. Hibernation isn't mere sleep, it's a specialized form of dormancy where metabolic rates plummet by up to 90%, heart rates slow from 200 to 300 beats per minute to as few as 2 to 3, and breathing becomes sporadic, sometimes ceasing for over an hour in species like dormice or bats. This energy conservation is key in food-scarce winters, allowing animals to live off stored fat reserves for months. Unlike estivation, summer dormancy, or torpor, short-term slowdowns, true hibernation involves prolonged physiological changes, regulated by hormones like melatonin and triggered by shortening days and dropping temperatures. Instinctively, animals prepare by hyperphagia, gorging on food to build fat layers, sometimes doubling their body weight as bears do by consuming up to 20,000 calories a day in autumn. But the science whispers even more calming secrets. During hibernation, animals recycle urea, a waste product, back into proteins, preventing muscle atrophy and eliminating the need to wake for elimination. This self-sustaining cycle means no eating, drinking, or waste production for half the year, a testament to evolution's elegant efficiency. In dens or burrows, body heat is meticulously managed. If temperatures dip too low, below 4 degrees Celsius for some, animals shiver to re-warm slightly, maintaining a delicate balance without fully arousing. Feel the tranquility in this. Nature has engineered a perfect rest where survival harmonizes with serenity.
Envision animals as master builders, sculpting insulated sanctuaries from Earth's embrace, where the chill outside fades into a warm, dreamlike cocoon. This hook draws us into the artistry of hibernation dens. Bears, for instance, excavate hillside burrows lined with leaves and branches, creating heat-efficient hideaways that trap body warmth like a natural blanket. As your eyelids grow heavy, let this image soothe you. These dens aren't just shelters, they're bioengineered retreats where temperatures stay stable, often 10-20 degrees C warmer than the frozen world above. Explore profoundly. Different species tailor their hibernacula uniquely. Ground squirrels dig burrows up to 2 meters deep, plugging entrances with soil to seal in humidity and warmth, while bats cluster in caves or attics, their group huddles conserving collective heat. Wood frogs take it to extremes, freezing solid in leaf litter, their bodies producing glucose as a natural antifreeze to protect vital organs, reviving come spring without harm. Hedgehogs curl into spiny balls in nests of grass and leaves, their spines deterring predators during vulnerable rest. Even insects like ladybugs enter diapause, a hibernation-like state, aggregating in thousands under bark for mutual protection. The preparation is instinctive and rhythmic. As daylight wanes, circadian clocks signal the start, with animals scouting locations weeks in advance. In Arctic regions, like with the Arctic fox or lemmings, burrows under snow provide insulation, the igloo effect trapping air pockets for coziness. This architectural ingenuity ensures minimal energy loss, allowing hibernation to last from days in warmer climes to 7 months in colder ones.
Remarkably, some animals arouse periodically, every 10 to 20 days, to readjust, a brief wakefulness that prevents total shutdown, blending rest with subtle vigilance.
What if studying these slumbering creatures unlocked secrets for human health? From space travel to medical miracles. This captivating hook connects animal hibernation to our world. Scientists explore bear hibernation for clues on preventing osteoporosis as these animals emerge without bone loss despite months of immobility. Let this thought cradle you. Winter's nap isn't just for wildlife. It inspires dreamy innovations for humanity's future. Bears maintain muscle mass by suppressing certain genes, a process that could aid bedridden patients or astronauts in zero gravity. Arctic squirrels' brain protection during extreme cold offers insights into stroke treatments, their neurons resilient to oxygen deprivation. Bats, hibernating in clusters, reveal social dynamics of warmth sharing, echoing how humans huddle for comfort. Not all animals hibernate fully. Some, like badgers, enter torpor variably, adapting to milder winters, a flexibility mirrored in birds that hibernate nightly to save energy. Myths dispel in this calm exploration. Bears don't truly hibernate, but enter a lighter winter lethargy, rousing easily and even birthing cubs mid-slumber, nursing them in the den's safety. Birds, like the common porwheel, enter torpor for weeks, their body temperature matching ambient air at 5 to 10 degrees Celsius or 41 to 50 degrees Fahrenheit, a rare avian feat. In tropical zones, hibernation flips to summer for species like lungfish, encasing in mud cocoons during droughts. This global tapestry highlights hibernation's adaptability, a soothing reminder that rest evolves to fit every niche. As the winter night deepens, imagine delicate birds, those eternal symbols of flight and freedom, tucking their wings close, hearts slowing to a feather-light rhythm, slipping into a state of profound energy-saving tranquility. This is the dreamy science of torpor in birds, a subtle cousin to hibernation that allows these airy creatures to embrace winter's chill without fleeing south. Hook yourself into this serene secret. What if the chickadee perched outside your window isn't shivering, but masterfully conserving its life force, dropping its body temperature by half to survive the coldest nights? Let these facts cradle you, exploring the biology, beauty, and breathtaking adaptations that make torpor a nightly or even weekly lullaby for our feathered friends. As you drift, feel the peace in knowing birds have evolved this elegant rest, turning scarcity into serenity. The nightly miracle, from frenzied flight to frozen stillness. Picture a tiny black-capped chickadee weighing less than an ounce, foraging furiously at dusk, then vanishing into a dense evergreen. By midnight, its body temperature plummets from a lively 42 degrees Celsius or 108 degrees Fahrenheit to as low as 20 degrees Celsius or 68 degrees Fahrenheit. Colder than a human fever, its metabolism slowing by 90 to 95%, heart rate diving from 500 beats per minute to a mere 50. This is daily torpor, a short-term shutdown lasting 4 to 12 hours, allowing the bird to save up to 35% of its daily energy budget when food is buried under snow. As your breaths slow to match, envision this. The chickadee awakens at dawn, rewarming in just 15 to 30 minutes through shivering and burning stored fat, ready to sing again as if untouched by the night's deep freeze. Delve deeper into the wonder. Torpor isn't uniform, it's a spectrum. Daily torpor, nocturnal, is common in small passerines like chickadees, wrens, and hummingbirds, triggered by cold nights in short days.
Their high surface-to-volume ratio means rapid heat loss, so torpor is essential. Without it, they'd starve in 1 to 2 days. Hummingbirds take it to extremes. The Anna's hummingbird enters torpor every night, dropping to 11 to 18 degrees Celsius or 52 to 64 degrees Fahrenheit. Its breathing halting for 20 to 30 seconds at a time.
Envision birds as instinctive engineers, selecting hidden nooks that amplify torpor's peace, like cavities in trees lined with moss and feathers, creating microclimates 5–10 degrees Celsius warmer than open air. Why does a verdin weave a fluffy nest ball from spider silk and plant down? To trap still air, reducing heat loss by 50% during torpor, turning survival into a soft embrace. Site selection is key. Cavity nesters like nuthatches and titmice burrow into woodpecker holes or snags where insulation rivals a down blanket. In colder climates, species cluster, bluebirds huddling 10–20 deep, sharing body heat to minimize individual energy drain. Hummingbirds seek dense foliage or sheltered ledges, their torpor amplified by low wind exposure. The porwheel chooses south-facing rocks that absorb daytime sun, pre-warming for easier arousal. In autumn, birds ramp up fat reserves. Chickadees cache thousands of seeds in bark crevices, retrieved by memory alone, fueling torpor cycles. During torpor, they enter a hypometabolic state. Blood flow to extremities halts, prioritizing brain and heart. Glucose levels rise as a cryoprotectant, preventing ice crystal damage. Arousal is a marvel. Shivering generates heat at 10 times resting rate, completed in under an hour to avoid predation. In milder winters, torpor bouts shorten, adapting flexibly. Studies show chickadees in British Columbia enter at 200+ nights a year, saving enough energy to breed successfully come spring.
Not all birds torpor equally. Larger ones like crows rarely do, relying on fat and flocking, while tropical swifts enter daily torpor year-round for efficiency. This diversity soothes. From Alaska's boreal forests to desert canyons, torpor is nature's universal rest for the winged world. Echoes in science and spirit, torpor's gifts to us. What if a bird's nightly trance held keys to human endurance, from deep space voyages to healing cold-stunned hearts? This enchanting hook bridges avian torpor to our dreams. Researchers mimic it for induced torpor in medicine, cooling patients to protect organs during surgery, inspired by how porwheels survive near freezing without damage. Deep immersion. Torpor reveals neuroprotection. Birds' brains resist hypoxia via upregulated antioxidants, informing stroke therapies. Hummingbirds' rapid arousal cycles teach metabolic flexibility, potentially aiding obesity treatments by toggling energy-save modes. Ecologically, torpor sustains ecosystems. Resident birds control insect pests year-round, preventing spring booms. Climate change challenges this piece. Warmer nights reduce torpor need, but erratic cold snaps strain unprepared birds, a gentle reminder of balance. Myths fade in this reverie. Torpor isn't fainting or weakness, it's superpowered thrift. Swifts in Europe enter 3–4 month torpor atop chimneys, bats of the air in suspended grace. Even penguins in Antarctica used regional torpor, cooling flippers while core stays warm. Globally, from Australia's tawny frogmouths to Africa's nightjars, torpor unites 50+ species in quiet adaptation.